Right now, we're near the end of our work now, and this particular video is on the petrol unit that we have to deal with, and I'll ask you please to make sure you edit the notes you have so that you'll be able to study from them when we're finished, all right? Very important. Now, starting there on page 5 of your notes, right-hand side, number 6 is petrol. You probably need to make a statement there in your notes that petrol comes from the naphtha or gasoline fractions, if you remember a while ago from our fractionation tower, the second last one and the last one, okay? The light gasoline, you need to know the fraction from which petrol comes, that's very important. Petrol is obtained from the fractionation stage in an oil refinery, is not very efficient in the car engine. It has a low octane rating. You could put in the word number there as well, a low octane number would be fine. The petrol from the fractionation process consists mainly of straight chains. These ignite in the cylinder of the engine, right? And you have this kind of work printed for you there already, but they ignite in the cylinder of the engine when compressed rather than when sparked. And this is known as auto-ignition and results in knocking. The engine will lose power and may result in damage to the cylinder. Let me decode that for you now. It's really very simple. Now, no one here presumes that you're a motor mechanic now and that you should suddenly be able to explain how the internal combustion engine works. But there are some simple little ideas you need to have that would help you along the way, and I'm going to develop them for you now, I hope. This is a cylinder of an engine, and in very simple terms, I think what we need to realize is this is the piston that goes up and down. And in the same way in which you would propel a bicycle, you push the pedals down every second time and it propels, okay? It transmits that energy to the wheels. In the same way, if the bicycle had no chain, then I'm afraid your energy couldn't go into the wheels. So that's basically it. Now what happens here very simply is this. The fuel is taken in through the inlet valve. It is then compressed by the piston. It is then ignited by the spark plug. And that causes an explosion which pushes the piston down just like you'd push down the pedal on your bicycle. So there's an intake, compression, spark, which drives the pedal down, and then finally exhaust, of course. The exhaust has to come out again and it starts all over again. Intake, compress, ignite and exhaust. The problem, unfortunately, is if a fuel isn't very efficient, and here's a difficult enough concept now. An inefficient fuel is one that burns easily. Surprise, surprise. It's a fuel that burns easily, meaning that it burns before it should. And that's the term called auto-ignition, which I'm going to get to in a moment. Automatic ignition. You only want the fuel to burn when you light it. If you do it at any other time, well then, since there are 4 cylinders in a car's engine, then 2 or 3 of them will be pushing down together. Now you should try it sometime, pushing the 2 pedals of the bicycle down together. You're in for a surprise, yeah? You'll go nowhere. In fact, you may fall off, okay? The whole notion is that you need to do it in sequence. And so if you have 4 cylinders, they must indeed light in sequence. If the fuel is inefficient, then 2 of the pistons will start pushing down together and it creates a vibration called knocking in the engine, and you'll damage the cylinder long term if that goes on. So they have to refine the fuel to make it suitable for its purpose. And basically that's what you need to recognize, that certain fuels, when they're produced, because they're just a long chain, they burn too easily. And if they burn too easily, they undergo auto-ignition, and that of course will damage the engine. Now, I'm going to refer to a moment in 2 reference fuels. There are 2 fuels you must be familiar with, and they're very important. I've models of them here for you now. I'm going to show you them, right? This one is called heptane. It's straightforward enough now. Hept is 7. And there's 7 carbons in that. 1, 2, 3, 4, 5, 6, 7. And that's a straight chain. Now, you can tell me what you like about it, but straight means one after the other. It doesn't mean a straight line. If I was drawing that on the board, you know, I'd put 7 carbons in a straight line. But that's what it looks like. It's tetrahedral, look. And there's 7 of them in a chain. Now, that will burn very, very easily. Okay? So it's not very efficient. And in fact, it is the worst possible fuel, heptane, right? The second one is the best possible fuel. Okay? And I have to make sure I get it right for you now. This is known as 2,2,4-trimethyl-pentane. Are you confused? Good. Okay, I need to draw it for you first of all, give you an idea. Pent is 5. that's pentane. And if it's branched, it's a much better fuel. If you have a methyl there, CH3, a methyl there, CH3, and a methyl there, CH3, you're going to get, the name of this will be trimethyl, methyl, 3 methyls. 3 methyls, and the parent is pentane. Now, when you're naming that molecule, of course, you'd name the longest chain first, then you'd identify the substituents, you tell me how many of them you have, and lastly, you tell me where they were. That's carbon number 1 in the chain, number 2, number 3, number 4, number 5. So 2, 2, 4, trimethyl pentane is the name of that molecule. I'll come back to it now in a moment. It's the name of that molecule. It's a very good fuel. Okay? 2,2,4 trimethyl pentane. Look, there are the locations. There's the quantity. That's the substituent. They're substituted for hydrogen. See, there's hydrogen at all the other places there. Sorry, no, I'm not putting in the hydrogens, but you know I should be all the time. Okay? Oh, there you go. That was pentane, and somebody swapped 3 of the hydrogens for methyl, so you try methyl, and they're located at the second, and the fourth. The second, and the fourth. 2 to 4, try methyl pentane. Now, I have a golden rule for you in organic chemistry. Numbers mean location, not quantity. Numbers mean location, not quantity, okay? They're only telling you where they are. That's the quantity, 3. Okay, but that's the location. You always use numbers for location of that. Now, this is a crumpled up molecule. There are 8 carbons altogether. 5 and 3 is 8, okay? And I'm holding number 1 at the moment in my hand. That's number, that's number 2, number 3, number 4, and number 5. And can you see at number 2, I have 2 branches. Now, maybe I'm not being fair to you now, but there's 2 branches. And at number 4, there's another branch. Okay, it's a crumpled up molecule. If that was a straight chain, it would be useless. Okay, but this one is a straight chain, it's fairly useless. Now, I better try and give you some idea in relation to the physical features of that. Let me get a sheet of paper for you. If you were to take some sheets of paper, okay, I'm taking some sheets of paper here now, and you want to know, how would you best ignite or burn that sheet of paper? Do you all accept that if I put a light at the bottom of that would burn very easily? And would you know why? You do, I'm sure, because there'd be loads of air next to the fuel and it would burn very easily. You know how you have warnings about curtains and certain clothing and all that near flames are very dangerous, okay? Because there's lots of air around it, so it could ignite very easily. Do you all accept if I took this piece of paper and I make it up into a ball? That's the same piece of paper. Now it will be much harder to light. It won't burn as easily. That makes it more efficient. Now, that analogy is rather important that you have that idea. I'm saying it again to you now, that if I took a regular page, it would burn much easier than the page when it's crumpled up. Therefore, the compact molecule is far better. The compact molecule, that's the straight molecule, that'll burn easily. Putting a match to that, it will burn. That'll burn prematurely, it will cause auto-ignition. And that's a problem in the engine. So they tend to have to refine. They have to basically branch the molecules to make them better. That's what you need to have. Now, these are 2 reference molecules, and you must know the name of both of them. One name is on the board already, and I'm putting the other one in here now. It's simply 7 carbons in a chain. 7 is right. And that's called heptane. Okay, and it's fairly useless as a fuel. It will burn too easily. Now, I hope that's not a contradiction. If the fuel burns too quickly, it's burning prematurely, and series of the pistons are all pushing down together. You want them to burn when you light them. So they go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And therefore the engine runs nice and smoothly. Now, you don't need any of the mechanics of that, but just to be aware, a long chain like that will burn too easily. That's a bad fuel. A branched chain like that will, of course, and I didn't bother enhancing the branches here, they take up much more space. The branched fuel is much more efficient. And that's the paper crumpled up into a ball, and that's the page when it's flat. That'll burn much easier than that, and that's effectively what we're actually talking about with that. And ultimately, that's what we're after. Okay, so let's just read on for a moment in this. It's all on the screen as well. Let me go through what's here for a moment and see, can I just qualify that for to make sure it's okay. I'll be back to defining octane number. The octane number of a fuel is a measure of the tendency of the fuel to resist autoignition. Okay, autoignition is something that'll come up now. Autoignition is when something burns prematurely. Okay, it burns automatically. You only want it to burn when you light it. Okay, that's very important. Okay, and it causes knocking. Knocking is an official science term. Causes a vibration in the engine. Okay, not good for it, by the way. Petrol formed from the fractionation process consists mainly of straight chains, which are fairly useless. Okay, consequently, these compounds ignite in the cylinder when they are compressed rather than when they're sparked. We want them only to burn when you light them. When they're compressed. Compressed comes before sparking. You don't need to even give that in the exam now. All you need to say is straight chains are inefficient because they undergo autoignition, which means they burn too easily. Okay, you only want them to burn when you need them to burn. Okay, this is called autoignition and results in knocking. The engine may lose power and you'll damage the engine long term if you persist with that. And they're my two reference molecules now that are very important. There are no circumstances now, I hope I'm not creating any impression with you, that you'd have to know the structure of the cylinder of an engine. Not at all. That's only there as a reference, okay? That's in most of the texts. Don't worry about it at all. It's only there to give you a sense of what's going on. Branched alkanes, such as 2,2,4-trimethylpentane, sometimes called isooctane because it is an isomer of octane. There are 8 carbons in that. 3 and 5 is 8. Okay, now please don't use that name. If you're asked to name it by that name. That's the systematic name. 2,2,4-trimethylpentane. If I ever write a name in organic chemistry, I'd write the parent first. I would put in the substituents next, and I would tell you where they're located last. I'd write it backwards. And I don't mean that in any silly sense now, but yeah, there's a total of pent is 5. I'd put that down first. Then there's methyl, and there's 3 of them there. And where are they? There's 2 at the 2, and there's 1 at the 4. You see what I mean? You build it up that way. And that's what you should be doing. Okay, that one does not undergo autoignition. It's the best possible fuel, right? The octane number indicates the efficiency of a fuel. The higher the octane number, the less tendency of the petrol to undergo autoignition. And you have a definition there in your notes. This is a measure of the tendency of the fuel to resist autoignition. Okay, it has a high octane number. It resists autoignition. It won't burn too easily, which is good. That's the point. You have to be careful how you present that. That's very important that you present it like that and that you be aware of that. Now, I'm moving on then so that we can actually rectify the problem that we've just spoken of. And here you go. The octane number is measured by comparing. Okay, it's in your notes now, that's in your notes. By comparing the fuel with a mixture of these 2 reference molecules. Now everybody please note, on the board here, these are 2 reference molecules. Normally when you're asked to name organic compounds, the request is that you should not exceed 4 or 5 carbons. They won't ask you anything else, except for the special molecules. 2 very special molecules. You are expected to know them and be able to draw them. Okay, and if you were being very fussy, you could put in all the bonds. You could put in the H's there as well if you wanted. Now, I don't mind that. I'm okay with that. But I'm just saying to you, you could do that for all of them if you wanted. That's 2,2,4-trimethylpentane. Please call it by that name, and please get to know that name well. And the other one is heptane. Now, the idea would be then, be careful with this, right? Good quality petrol. They refer to this as an efficient fuel, and they refer to that as an inefficient fuel. And that's okay, I have no problem with that. Okay, a very efficient fuel. Good quality petrol has an octane number of 97. Would you mind changing that, please, to 95? 97 isn't on sale anymore. Okay, and change that to 95% and 5% heptane. Now listen to me, please. I've put in isooctane there for the name of that. That's only to keep the notes shorter. I'd much prefer if you'd use that name. That's a lazy name now, don't use it, okay? So if I tell you, when you go to the pump, that the octane number is 95. I am telling you that the petrol you're about to put into the tank has the same efficiency as a hypothetical mixture that would be made up of 95% of this guy and 5% of this. That's what it means. 95% of the good stuff and 5% of that. In other words, these are used as reference molecules. When we actually put petrol in the tank of the car, by the way, we don't know what's in it. All we know is that it was petroleum at one stage, it was this, and it was refined at enormous expense, and it was refined several times until they got an octane number of 95. Until, in other words, it had the same efficiency as 95% of that and 5% of that. And every time you go back to the pump and you fill the tank again, you're not necessarily putting the same hydrocarbons in there, but it has the same octane number. And that's something you have to just be aware of when you're working with that. But there's no big deal to it. But you must know the two of them now. That's very, very important, right? So 95, I prefer to see in your notes there, because 97 is for high performance engines. And it's not on sale to the general public as a rule, okay? But it's equivalent to 95% of this fellow and 5% of that. It's that efficiency. So you're using them as reference molecules. And they'd ask you that. What are the two reference molecules used when measuring the efficiency of petrol? And you either know them or you don't. And you might be asked to draw them, okay? They're special molecules now. They have a particular pivotal role on your course. You must know them. Please attend to them. They're very important. Good quality petrol has an octane number of that, and that's very important. Now, the next piece, you'll need to add some notes to it. It's very important you do that, and that we can deal with it that way more than anything else, okay? And I'm going to do that next. Factors which determine the octane number of any fuel. Factors which determine the octane number of any fuel. And of course, you have three answers, right? Number one is the length of the carbon chain. The length of the carbon chain. And basically, will you write in there, please, the shorter the chain, okay, the length of the chain, the shorter the chain, the higher the octane number. Shorter the chain, the higher the octane number. There's a space in your notes now. Factors which determine the octane number. Number one, the length of the carbon chain. And please make a statement there. The shorter the carbon chain, the higher the octane number. Now let me try and explain that to you. Why would that work? I've already used the idea of a sheet of paper. If you put a match to the bottom of that or a flame to the bottom of that, it'll light immediately. If I take the same paper, light it and it will burn. If I take the same paper and I tear it up, will you accept now that that won't burn as quickly as the single page? Why? There's far less air in there. It'll be harder to combust. And that's true. And that's exactly what you do all the time. You realize that it would be far easier to burn that than to burn this, even though it's the same page. And that's very, so if you can shorten the chains, they're not likely to burn as quickly as the long ones, okay? And that's ultimately what we're after with that. I hope that's okay. That's the first one. Number two, the number of branches. Will you write in there, please? The more branches, the higher the octane number. The more branches, the higher the octane number. Very good. The more branches, the higher the octane number. Okay, very good. And the third way, okay, we're talking here now about the factors which determine the octane number, what will keep the fuel efficient. And the third way is the presence of a cyclic compounds, okay? And will you write in there, please? Cyclic compounds have higher octane numbers. Cyclic compounds have higher octane numbers. Okay, are you all right with that now? Now that's the effect. And now we in the final part of this video, we will be saying how we would achieve that. Okay, before we do that, I want to say a few things to you about unleaded petrol, because it might just come up in an exam. The kind of thing I'm talking about now is when exams are normally constructed, they like to make them relevant to everyday situations, and you know, they'll be drawing petrol pumps for you and that kind of thing. Okay, and they'll be writing octane number 95. And they'll be writing unleaded in here. And they'll be asking all the questions. What do you mean by octane 95? And what do you mean by unleaded petrol? Okay, that kind of thing is what we're at. And no smoking up here. And they'll ask you, Oh, why must you not smoke? Okay, I'm joking, of course, but you know what I mean. That they tend to apply it to an everyday situation, and I hope that that's okay with you. You know, that you have a sense of what is the relevance of your chemistry, in other words, very, very important. Now, remember in chemistry, when you're asked something about an everyday application, they're looking for an answer from a chemistry student, okay, not Joe Bloggs. They're looking for an answer, a chemical answer. So if there's not chemistry in your answer, you're not going to get marks. So please attend to that, won't you, when you're doing that. Unleaded petrol, I've down here, write a note on unleaded petrol. Now, in your own time, you can put this together. I'll give you some food for thought, I hope, that you might be able to work on. Now, please, I have to be fair to hear about this now. This is not that simple, okay? And you don't need all of this, but I'm going to deal with it. Let me just dim the light for you for a moment so you can see that, okay? I'll read it to you now, please, and you go to the back of the page of your notes if you haven't room there, okay, to write a note on unleaded petrol. When a lead compound, and the compound is called tetraethyl lead. I'm going to get rid of my two friends here. Would you be able to redraw them again now? Now that I have them erased, would you be able to draw them again? That's very important now that you can do that you're not copying, okay, that you have a sense of that. Tetraethyl, there's ethyl, C2H5. There's lead, Pb is lead. Lead is number 82 in the periodic table, and tetra means 4. Tetraethyl lead is added to petrol, or was added to petrol, okay? And basically, it was an inhibitor, and it prevented the fuel from burning too quickly, okay? It reduces autoignition. When a lead compound called tetraethyl lead is added to petrol, it reduces autoignition. And that's what they did with leaded petrol. However, they discovered that lead pollution caused by the exhausts of cars has necessitated phasing out lead petrol. Okay, now I'm trying to give you the origin of unleaded petrol. Fado, about 15-20 years ago, there was lead petrol on the market, and when you went to the filling station, there was 2 pumps, leaded and unleaded, and you took your choice. The leaded petrol had that compound in it, which meant they didn't have to refine the petrol as much, but they chucked some of this lead compound into it, and it prevented it burning too soon. But of course, they discovered very quickly that that particular petrol was giving out emissions which had lead in it, and lead is toxic. It's highly dangerous, and if inhaled, it would have huge implications, and there were health hazards with it. They had to withdraw it fairly quickly. Okay, so I'm making the statement there that lead pollution caused by cars' exhausts has necessitated the phasing out of lead. Now, this statement is flawed. Will you be careful, please? Unleaded petrol has a low octane number. I don't mean that now. What I mean is the leaded petrol, after you take the lead out, you want to rephrase that. When the lead is removed, the octane number will go down from 95 to about 70. By the way, 70 is disastrous, okay? You'll destroy your engine, okay? So when you take out the lead, I don't mean unleaded petrol as the modern term, but once the lead has been removed from the petrol, the octane number will go down from 95 to 70, okay? And that's very bad. And so consequently it says, and this is important, this petrol has to be further refined. Once you've taken out the lead, the petrol has to be further refined to increase the octane number. So when they took out the lead, the octane number went down to 70. So the chemist had to go to work to bring all the petrol up to a standard where the octane number would be 95. And that involved further refining, which is the final category we must do. Are you okay with that? That's exactly what we have to be aware of now. Now, please, you don't have that in your notes. I've just asked you to write a note. Keep it very simple. All you have to say is, Fado, there used to be a lead compound in petrol. I think I'd want you to know it, tetraethyl lead. Okay? And that was great for increasing the octane number. Unfortunately, the emissions from that petrol were highly dangerous. There was lead in the emissions, and that's considered very dangerous, very toxic. Okay? And so it had to be withdrawn. So the chemist had to go to work. When you take out the lead, the octane number goes down. So the chemist had to further refine the petrol to bring the octane number back up to 95. Okay, and that's all you need to say. And this petrol had to be further refined to increase the octane number. And how would you do that then is the question, of course. And that's on the last page of your notes, of course. It's on page 6 of your notes. So will you go to page 6 of your notes, please? And you're going to get this. Page 6 of your notes, you're going to get this. Okay, now please, will you be careful what you record here now, because some of what's in your notes is fine and some isn't. You'll have to qualify it, okay? There are 4 things you would do to petrol to bring up the octane number, and I hope you're okay with that. There are 4 things you'd have to do, okay? Let me give you some light now again, but that's what we're dealing with, okay? Now, the octane number can be increased as follows, any of the following. Isomerization. Now, we need to make some comment on each of these. There's a space in your notes for each of them. Isomerization, okay? Basically, what you're doing here is, okay, this is the conversion of a straight chain into a branched compound. That's what it is, okay? And you don't need these numbers at all. But look, 1, 2, 3, 4, 5, 6. And by branching it, you get 4 with 2 branches. Now, that's much better than that. And you know where I'm taking you now. You know where I'm taking you. That is much better than that. It'll be easier to burn that than this. Okay, so this is a higher octane number than this, and that's what you're on about. That's isomerization. Converting it to a branched chain is very, very important. Now, please, I don't want those numbers at all. Under no circumstances do you need to know those numbers. Just that has a higher octane number than that, and that's what you want. Now, I'll give you a moment because you will have to write this down. It's not in your notes. All you have in your notes is isomerization. These are all the methods that a chemist would use to increase the octane number of the fuel. Having taken the lead out, which was very good at its job, by the way, but was causing pollution, they had to find an alternative way of raising the octane number, and that's one way of doing it, okay? So a straight chain is converted to a branched chain in isomerization. Okay, and that's an example of it. I'm repeating again, you do not need those numbers. You do not need those numbers. Next then is catalytic cracking. What is that? As the name suggests, this is the breaking down of a long chain into a shorter chain, for which there is a higher demand. It would be better there if you said, which has a higher octane number. Forget about the demand. Okay, breaking it down from a long chain to a short chain, which has a higher octane number. And what am I going to show you now? I think you know. A long chain into shorter chains. That's the same page. And therefore, this has a higher octane number than this. Now, there's a logic in that, I hope. And you always go back to the concrete in chemistry. You go back to something that's very fundamental when you're talking about it, okay? Don't be trying to use sophisticated language at all. A long chain will burn easily. Chop it up in little pieces and you'll find it harder to burn it, which is good. The octane number goes up then, and that's exactly what you want, and there'll be nothing to that. And remember the rules on this already. You have this done already now, and there'll be no problem with it. I hope it's okay with you. Okay, what you have there, look, if you look at it, you have a compound there, 3, 6, 9, 9 and 2 is 11. And there's a 3, and there's a 5, that's 8, and 3 is 11, okay? Everywhere there's a crack, there's a double bond. A double bond here, a double bond here, no double bond there. Same number of carbons, and a double bond everywhere there's a crack, okay? Now, they would have a much higher octane number than that. That's the full page I was showing you, and they're the little pieces that are torn up. So that would be much better than that. So that's the second way of doing that. Very, very important. Are you all right with that, everybody? Good. The third way then is reforming, sometimes referred to as dehydro cyclisation. Now, how are you fixed with that? Okay, reforming, dehydro cyclisation. That is the conversion of a straight chain compound into a cyclic compound with the elimination of hydrogen. Okay, dehydro means dehydrogenation, taking out the hydrogen. Dehydro cyclisation. That's C6H14, that's C6H12, and that's H2. All right, and that's what you're doing. Now, that's a better molecule than that in petrol. That's the ball. When we roll it up in a ball again, that's the same idea. The page rolled up in a ball, that will burn much faster than that. That's much more efficient than that. And that's ultimately what you're after. Now, please, keep it simple. You don't need to be anywhere technical with it. Reforming, dehydro cyclisation. Okay, sometimes the isomerization gets worked in here as well, as you know, and don't get confused with that. Now, the last one would be new to you, and you'll have to be careful. Now, am I rushing you, I wonder? Are you okay? Can I give you a moment on them in case you want to look through them? Okay. How will you increase the octane number of a fuel? Right, I'm saying it again to you now. They put lead into petrol originally, and it rose the octane number, making it very efficient. But the emissions were very dangerous, so they had to take away the lead out of the petrol, and it became known as unleaded petrol. But unfortunately, when you take the lead out of the petrol, the octane number goes from 95 down to 70, useless. How are you going to get it back up to 95? There you are. Isomerization. Convert straight chains into branched chains. Cracking. convert long chains into short chains, and reforming or dehydro cyclisation. What's that word now? Dehydro cyclisation is a word you're expected to know. Dehydro cyclisation, okay? Take a straight chain and turn it into a cycle, and it'll be harder to burn, and therefore more efficient. The octane number goes up. Very, very important that you're working with that and that you can present it that way. All right, good. Now, the last part of that. Now, if you have any issues with this, you pause your video and you go back, of course. That's very, very important that you do that. Now, number 4 is adding oxygenates. This is new to everybody now. This is an additive that goes into the petrol that will increase the octane number. Oxygenates is a fuel with oxygen in its molecule. We haven't done any up to now. Everything with us has been hydrocarbons, and we haven't added oxygen. We haven't had oxygen involved. When you take the next layer of organic chemistry, you'll be going into alcohols, aldehydes, ketones, carboxylic acids and esters, and they all have oxygen in them. Okay, just be aware of that when you're dealing, there'll be no problem. Okay, and here are 3 typical molecules that would be used here. 3 oxygenates that are commonly added to petrol are shown to you there. You might need now, in this instance, you might need to qualify that. Okay, I have little or no material on that. You need to take that down, I suspect, and that would be no harm to do that. And their octane numbers are given to you there. Under no circumstances would I want, I'm covering them for the moment, under no circumstances would I want you to know those. Okay, under no circumstances would I want you to know them. Now, will you be careful, please, just when you're working through that you have got those particular molecules as you want them. Okay, very, very important. Okay, that's methanol. That's ethanol. Okay, that's the first alcohol, the second alcohol, and that's a dodgy enough molecule. Okay, it's methyl tertiary butyl ether. Now, please don't go there. They'll ask you to name an oxygenate. Why would you invite that to the party when neither of them will do fine? Okay, you don't need to know all these, but you need to know that's the simplest alcohol, that's the common alcohol, and that happens to be, in this particular case, will you take it that's a complex molecule. Okay, that would have been an ether. Okay, it's an ether, and ethers aren't on your course, but that is a special molecule. Now, they won't ask you that. They might give it to you as a different matter and ask you, what is it? In other words, would you recognize it? We saw it again. That happens to be an oxygenate. Any one of the 3 of them would be added to the petrol to improve the octane number. That's very important. Now, that's not in your notes. I'm acutely aware of that. I'll be happy to call that now MTBE. MTBE, okay? Someone was telling me once they remember as MTV, okay? And MTBE. But whatever you're doing, please, that will be the name. Ethanol and methanol are the 3 chemicals added to petrol to improve the octane number. I'm uncovering that now. Please, you do not need to know that. Something with an octane number of 114 is a super fuel. Okay, it's the super fuel. Will you take it, please? That they add small amounts of that to the petrol to improve the octane number. Oxygenates, very important that you know this, are far less polluting than hydrocarbons of the same octane number. So if you could run your car on ethanol, the emissions would be very, very good. They'd be very, very non-polluting. You'd want a large bank balance, by the way, if you were running your car on ethanol. Okay, but I'm making that point to you that, like, there are fuels. We have to be realistic about fuels we burn. Fuels have to be affordable. Okay, that's very important, right? That we recognize that. And ultimately, will you take it, please, that with an oxygen in them, they're far less polluting than hydrocarbons. And that's very, very important. There's a little bit at the end of your notes now. We're almost there. There's a little bit at the end of your notes that I want to mention to you. Make sure you're okay. It mentions hydrogen. And that came up in a recent exam, and a lot of people are compromised. This has nothing to do with organic chemistry, but hydrogen is a super fuel. And because we're talking about fuels here, we better just be aware of what's happening there. I think you have enough in your notes already. You won't have much to add. Hydrogen is an excellent fuel as it has a very high kilogram calorific value. There's a lot of heat in it. It is used as a fuel in spacecraft, the fuel cell, and in the pollution-free internal combustion engine. There are cars that are propelled by hydrogen. The one problem they have is they need a reinforced tank to store that gas, and that has issues in its own right, okay? But it's a very, very non-polluting car, okay? There would be no pollution whatsoever from it, and I think that's rather important, right? That you'd be aware of that. So it's used for pollution-free internal combustion engines, okay? It's produced commercially in 2 ways, and I've just mentioned them here. I don't think you need them at the moment, but certainly at a later stage you might want to have heard of electrolysis. I'd like to think electrochemistry was done first. You're unlikely to be dealing with that other than it is a super fuel, and that's effectively where we want it, okay? Now, that brings us to the end of this particular category, and it brings us to the end really of your work for this particular term. Now, can I say just 1 or 2 things to you before we finish? You will be getting an exam in chemistry which will be practically identical in structure to the one you got in March. That had 6 questions in it, 6 questions, and you're asked to answer any 4. Okay, it will be the same style now, and you know my limitations on this now. I don't want you answering 6 questions. I would very much appreciate if you would read all 6 and pick the 4 you do best in. I want you to put all your energy into answering 4 questions only. Okay, if you answer a 5th question, I won't mark it. Okay, please take time, make choices, be sensible, and you'll be examined in everything you have done since last September. So it's important you revise everything up to and including this video. Now, I hope you're okay with that and that you're clear as to what's happening, because it is important that you do that. Now, the paper will be available to you on Monday week. Okay, next Monday it'll be available to you, and I would appreciate very much if you will deal with it at the appropriate time. Okay, it will be returned to me for marking, and I'll go through it then. But please, no excess questions, only the questions you're choosing to do, and you'll have to cover everything you've done this year. Just revise everything. I can assure it is a very reasonable paper with lots of choice. And your 4 questions, the rule is 20 minutes is an hour and 20 minutes, and you have 10 minutes for reading the paper as well. So that's an hour and a half. Now, the best of luck to you. Focus on what you've done now. Don't be trying to add anything further to it, and you'll do very well in this exam. Well done now. Keep up the work. Mind yourself.